today's lesson is the application of trig functions. Now, trig functions can be found in the real world in a lot of different places. So, real world applications of trig functions. You might see tides. So you might have a high tide and then a low tide and then a high tide. That's a cyclic function or a periodic function. High tide, low tide, high tide, low tide. Now this line through the middle, that's our average tide. You might also see anything that's cyclical, anything that repeats over and over and over again. Let's take a look at this one here. We're going to look at a pendulum in this video. Now, you've seen a pendulum before. This pendulum, when I press play, is going to swing down, it's going to come to the top, it's going to swing down, it's going to come to the top again. Now, this is going to be modeled by a trig function. So let's take a look at it first. Okay, so you can see that it moves quite quickly through the middle here when it's down the bottom, and then it starts to slow down, stops and changes direction. Starts to slow down, stops, changes direction, okay, and so on and so forth. Now this can be modelled, I'll just wait for it to be at the top. Okay, so this can be modelled by a cosine function or a sine function, doesn't matter how you model it. Just to draw it so we get a basic idea. Now if I take, this isn't very scientific here, but if I take a ruler, I'm going to take a ruler here, I'm just going to measure how high that pendulum is from the bottom of the YouTube video. Now it's 4 centimeters high off the bottom of the YouTube video. Obviously, if you're watching this on a different screen, you're going to see that differently. Let's just assume it's 4 centimeters. I'm also going to look at it at the bottom of the trig function, about there. Now I'm not being too exact here, but it looks like it's about 1 centimeter off the bottom. Okay, so at its highest, this pendulum is 4 centimeters, and at its lowest, this pendulum is 1 centimeter. Now that means that it's going to have an average height. If I can find the average height, that's maybe about the average height of this pendulum here. That's halfway between the highest it gets and the lowest it gets. So its average height, 4 plus 1 is 5, divided by 2 is 2.5. So the median height of this pendulum is going to be 2.5 centimeters. Now, I know that I'm going to use it as a cosine function. That means that it starts at its highest point. It starts at its highest point, comes down to its lowest point. So it starts at its highest point, comes down to its lowest point, and then comes back up again to its highest point. Okay, let's see how that works. Ready? I'll press play here and we'll follow it along on this thing. It's at its highest point, down to its lowest point, up to its highest point. Okay, and then it'll repeat from its highest point, down to its lowest point, back up to its highest point. Repeating again, from its highest point, down to its lowest point, up to its highest point. Okay, that's how our pendulum works. Now remember, this can be modelled via a cosine function. So a cosine function can be written as a cos b x plus c plus d. Okay, and we've already got a few pieces of this puzzle here. We can see that the amplitude is the distance from the middle to here. That's 1.5 centimeters. So 1.5 cos b x. Now the c value. The c value represents a sine shift, but because we're modelling this, it's probably easier to model it, a phase shift. Because we're modelling this ourselves, it's probably easier to model it without a phase shift at all. That is, it starts from the highest point and it comes down. So our c value is going to be 0. So bx plus d. Now remember, d is our vertical translation. Here's our origin of 0. The mean value, or the median value here, is 2.5. So we'll call that 2.5 there. So 1.5 cos bx plus 2.5. Now remember that this is our height and this is our time in seconds. So we really need to know how long it takes for it to get from highest point down to lowest point. And if I press play here, okay, using a stopwatch, I've come up to about 2 seconds that it takes for it to go from here to here. From highest point to highest point takes about 2 seconds. So that means that the period is equal to 2 seconds. Remember that the period is period equals 2 pi on b. So if the period is 2 equals 2 pi on b, we can find out what our b value is by rearranging that. And we can see that our b value is simply pi. Okay, so that means, I'm just going to write it over here, that means that our final function is y equals 1.5 cos pi x plus 2.5. Okay, you can put a bracket in there if you want to. Your calculator probably wants a bracket in there as well. Y equals 1.5 cos pi x plus 2.5. Okay, so what we've done is take something from the real world, pendulum, and we've created a function that models that. That function can be used in a variety of different ways. One of the ways that we can use it is to make predictions about what will happen in the future. Before I move on, let's take a look at our calculator. Okay, it's really important that you're able to put that into your calculator. Now most of you are probably pretty familiar with it. If you're not though, go into graphing mode. Now it's important, I'm just going to go into setup here, so shift setup. Just make sure that you're in radians mode here, otherwise you're going to run into trouble. You can choose degrees, radians or gradians. Choose radians, otherwise you run into trouble. Okay, once you're there, type in your function. It's 1.5 cos shift pi x plus 2.5. Okay, I'll just draw that. Okay, you can see that my view window is a bit funky here. I just need to change the view window a little bit. I need more of the y-axis, so I need to make my y maximum a little higher. Go to view window. Now we already know, because we drew it gets up to a y maximum of 4. So I'll just put the y max as 5 so I can see what's happening. There's really not a need for the y minimum to be -3 either. That goes all the way down here. So I'll just set the y minimum to -1. The reason I choose -1 is the reason I'm choosing -1 is so I can see the x-axis in my drawing. Okay, that'll do. Let's draw that. Okay, so that gives us our function drawn on our calculator. Now, let's say we wanted to know. We could answer a couple of questions here. One of the questions we could answer is, what is the height after 7 seconds? Okay, so what is the height after 7 seconds? So we want to know what is our y value when the x value is 7. Okay, so we can use our G-solve to do that on our calculator. Actually, just need to go back into my view window. I've only got an x max of 6.28, but we want to know an x of 7, so I'll just change that to an x max of, say, 10. You can see that that just gives me more of my graph to play with. Now we go into G-solve. Now you can see that there's a, sorry, I should do that again. We go into GSolve. There's a bunch of different stuff that it can tell you. It can tell you the y-intercept. It can tell you if there's any roots. There's no roots because it's not passing through the x-axis. Maximums and minimums. We want the next page though, so F6. Now we want to know a y value, so we should press the y calc button. We want to know a y value, we know an x value, so we'll press the y calc. Enter an x value. Now we want to know 7 seconds. Okay, and it tells you straight away that after 7 seconds, here's our little point here. So, calc, y calc, x equals 7, okay? And when x equals 7, y equals 1. Height equals 1 centimeter. You can see it's right down the bottom of its swing there. Okay, so that's one type of question you could get asked. The other type of question is obviously the reverse of that. When will height be 3 centimeters? When will the height be 3 centimeters? Okay, so using our calculator again, we can GSolve. Now we want to know a height, we want to know a time given a height. So we do the opposite here. We want to know an x value, so we use the x calc. We want to know an x value, so we use the x calc. Alright, so we've got a y value of 3. Now, you'll notice here that it gives you one value right here, okay, way back over here somewhere, because there's a whole bunch of different values. So it's going to have a height of 3 at minus 5.6 seconds. It's going to have a height of 3 at 4.39, at 3.6, at 2.39, this is all negatives, at negative 1.6, at negative 0.39, so on. You can see a whole bunch of values here. So when will height be 3 centimeters? If you're asked a question like that, you'll be given some more info, like when will height be 3 centimeters after 10 seconds? So if we need to go after 10 seconds, it's whatever comes after this one. So I might just need to change my view window, give it a max of, say, 12. Oops. Okay, I'll just do that x calc. Now we want to know height of 3 centimeters after 10 seconds. Okay, so you can see that at 10.39 seconds it will have a height of 3 centimeters. Okay, so this is a bit of a, I guess, introduction to some applications of trig functions. It's been a longer video than I would have hoped, but hopefully you've got an idea of some of the things that you can do with trig functions. We might run through another example in another video, just a really short one, so you can get another idea of some other things that this works with.